This video is going to walk through an application of rational equations. This is a really common type of problem called a work problem, even though work has nothing to do with this particular example. Okay, I will give you a second to pause the video and read that whole question to yourself. So what we are looking for is the speed of the wind. And my biggest helpful advice to you is every time you start one of these problems, start with your variable first. What is it that we are trying to solve for? Well, in this case, we are asked specifically, what is the speed of the wind? So I'm going to let that be my x. X is equal to the speed of the wind. That should be your first step. Anytime we need to use the speed of the wind, which remember, we don't know yet, it's still an unknown, we'll just call it x. And then we can build equations off of that, or build expressions off of that. Another reminder, something I'm sure you've seen in the past, a very simple equation called d equals rt, distance equals rate times time. Makes sense if you're driving at 5 miles per hour for 2 hours. The total distance you've traveled is 5 times 2. But that d equals rt can be manipulated also. If you divide both sides by r, you can say that t equals d over r, or you could also say that r equals d over t. So those are three versions of the same equation. It makes sense, rate is the distance you travel divided by the time that it takes, miles per hour. That makes sense. Okay, so turning now to our example here, we're looking for the speed of the wind, which means in order to find that, we're going to have to build an equation, some statement of fact. This expression is equal to this expression, and there's the speed of the wind is somewhere a part of that expression, and then we'll be able to solve the equation. Building the equation is the first step, solving it's the second. So in order to build the equation, we're going to take the information that they told us. The plane cruises at 480 miles per hour when there is no wind. So let's break this up. The flight is going from San Francisco to Chicago. So we'll go with to Chicago, and then to San Francisco. What I'm doing is breaking up the flight into its two components because it's going to take a different amount of time on the way east than it does on the way west. Now, the distance is the same either way. It's 1,850 miles either way. But the rate at which the plane is flying is different. When it is flying to Chicago, the plane's engine itself is making it go 480 miles per hour. But it is being pushed along, it is being made faster by whatever the wind speed is. So its new speed is 480 plus x. Meanwhile, on the way back to San Francisco, the plane can travel at 480 miles per hour, but it is slowed down, its rate is decreased by x. So the rates to Chicago and to San Francisco are different, which means the amount of time it takes to get to Chicago and to San Francisco is going to be different also. I cannot just take this 7 3/4 hours and cut it in half. That won't work because it's not an equal amount of time. And they don't give me any more information. They don't tell me how much more time it took. But what I can do is use the t equals d over r equation. The time it takes to fly to Chicago must be the 1,850 miles it flies divided by the speed at which it's going. And the flight on the way back to San Francisco must be the 1,850 miles that it's flying divided by the speed at which it's flying on the way back, 480 minus x. So even though I don't know either of those times independently, I do know that the total is 7 3/4 hours. So what I can say, since the total is 7 3/4 hours, is that if I were to add up these two times, so that's 1850 over 480 plus x, plus 1850 over 480 minus x, those two must add up to 7 3/4. Now, I will never use a mixed number when I'm writing an equation. If you want to call that 7.75, be my guest. I would prefer to use fractions because not every fraction turns into a pretty decimal. So I'm going to write it as 31 over 4. And so now we have an equation to solve, which we learned in our previous video. We can solve by multiplying both sides by the denominators, to cancel out the denominators, which I'm not going to do this whole thing, but would mean multiplying both sides by 4 and 480 plus x, and also multiplying by 480 minus x, which means I'm going to have to do that on both sides. Now, I'm not going to write all that down because I'm not going to sit here doing that multiplication right now. What I want to show you for this example is how you can also solve equations on Desmos or any other grapher. We've seen versions of this in the past. If I want to solve an equation, remember it was 1850 over 480 plus x plus. Notice how, by the way, when I want to make a fraction, I hit the fraction button first. That way I don't have to worry about parentheses or anything like that. What I want to know is, when does that equal 7 3/4? So what I'm going to do is, instead of just graphing 31 over 4, if I graph y equals 31 over 4, there'll now be a line at 31 over 4. And what I want to know is, what does x need to be? What does the wind speed need to be in order for this graph, which represents the total time it takes to fly the round trip, divided by the total time it takes to fly a round trip, depending on what the wind speed is. I want to know when that reaches 31 over 4. Now, I can't see it because when the wind speed is 0, the total amount of time, actually I can see it. Oh, I didn't even notice. It is very, 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 very close. The total amount of time is never really going to be that different from 31 over 4. So if I want to find out when they hit each other, meaning when that red line, and when the wind speed is 0, the total time is a little bit less than 31 over 4. But if I move on down, I can see it's slowly catching up, and right there I can see the intersection is at 35.195 miles per hour. So that would be the wind speed at which the total amount of time reaches 7.75 hours. Any faster than that, any stronger wind speed, and it'll actually start taking a lot longer for the flight to make it.